Hello everybody, welcome back. So we have analyzed the flow rate per unit depth and the shear stress in the previous video. So in the next video, we're gonna make things dimensionless. So let me write part F. No. We make things dimensionless. Okay, but before I want to get to the specific of the problems, I want to make some comments for y'all because I think there's a systematic way to approach these types of problems. Okay, let me write. So, before we start, I want to comment a little bit on the structure of these problems. Okay, so what is all this about? So let's say you have a property C. Okay, I think this pronoun like PSY, like not the Gangnam Style guy, but you see what I'm saying? It's a Greek letter. So it is defined as C equal to C star times CH. Okay, so why is C star? C star is the dimensionless group. And what is CCH? CCH is characteristic properties. Okay, so what are some examples of these? Okay, let me give y'all some example. Okay, this example is based on experience. Okay, based on experience. It's just on the collection I have doing the homework, but I think it's gonna be useful. Okay, let's talk about length. Okay, so for length, so L is usually equal to L star. So L is L star times LCH, right? But what is LCH usually is? So LCH usually is delta for the thickness, D2 minus D1 if you have for concentric flow. Okay. Let's talk about velocity. So velocity is, let's say it's U, right? So U is U star times UCH. So what is UCH usually is? UCH is usually UM, mean velocity, for fixed one. U, big U for moving one. Okay. And you can add more example, dot, 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 dot. Okay. How about flow rate? Flow rate is Q, right? And Q is Q star times QCH. Okay, so what is QCH? QCH is usually UCH times LCH square, where UCH is UM and LCH is D. D is stand for diameters. Okay, it can change. I'll show you. It's very specific to the problem. Okay, so stress. So tau W is usually T star, tau star times tau CH. Tau CH is usually rho times U infinity square. Okay, so this is some example I have. But how about this problem? So let's say, what are we using? So in this problem, We have two actually. So first is our velocity u. So our u star times UCH. And what does the textbook pick for UCH? The textbook, they pick V0 for UCH. Okay, and the next dimensionless group we can create is for our length x. So x is equal to x star times xch. And what does the textbook pick for xgh? They pick h. So in conclusion, let me write something. Sometime characteristic property is just a reasonable or important constant. So in this state, you say for, let's say for UCH, right? For characteristic for velocity, we have V0, okay? It's a nice constant. We can pick that as a candidate. XCH, okay, we have H. H is like the bound, so it's a nice constant too. And it simplified the length. We can pick that for the characteristic length, XCH. I think that's what it comes to mind when the textbook creator create these problems. Okay. Now, if you want to create some dimensionless group, you have to do some math, some transformation, okay? Unfortunately, so let me write. So now we need to do some mathematical transformation to get the dimensionless profile. Okay, so how do we do that? What do we want? So we want u star, right? As a function of x star. Because u star is the dimensionless velocity, x star is the dimensionless length. We want them. Okay, so where do we start? So we start with the original one. So u of x. Remember what is our u of x? We get it on previously already. So it's rho times g times x squared over 2 mu minus rho times g times h over mu times x plus v0. Okay, let's do it with me, do it step by step, and we'll get what we want, okay? So I think this is good now. I think we'll stop the video and see you on the next video. And we will do that.